Hello and welcome to this session. So in this video, we are going to look at the hypothesis testing. Okay, we are going to explore the basics about hypothesis testing. So as you might be aware, hypothesis testing is one of the statistic methods that are used to make a decision or inferences about population parameters based on the sample data that you've been given. Okay, so what is required in hypothesis testing? What is simply required is for you to state the hypothesis. Okay, in that case, you have got two hypotheses that you are stating. There is a null hypothesis testing, which is simply the hypothesis which states that there is no effect or difference, or it's simply a statement of no change or association. Okay, so there is also another hypothesis which is an alternative hypothesis. The alternative hypothesis simply it is an hypothesis that states that there is an effect or a difference exists. So in the first one, you are saying there is no difference, there is no change, there is nothing that is happening. But for the second one, it's an alternative. So there you're able to say there is an effect or a difference actually exists. So you're trying to compare the two. Then the second thing that you do, you have to choose the significance level. So for the significance level, in most cases, it is always stated. Okay, just a minute. So for the significance level, okay, here it is always stated. So in most cases, if it is stated, you're going to find sometimes it is at 0.1, sometimes it can be 0.05, so you can 0.05. So it depends, but you're always given the significance level in the question. So the significance level will always be given. So the most common use is 0.01. So it is 0.01. You have 0.01, 0.05, 0.10. Okay, those are the most common levels that are used. Okay, for the significance level. Then you have to select the appropriate test. So as you might be aware, there are two tests. There is a Z test, which is a Z test as we pronounce it here in Zambia, as well as the T test. So for the Z test, it is mostly used when the sample size is large. Okay. In that case, if the sample size is too large, you're going to use the Z test. Okay. In that case, we are saying the sample size is maybe, let's say, n should be greater than 30. That is, you're going to use the Z test. But in an instance where the sample size is too small, you're going to use the T test. Okay. Then the fourth step, you're going to calculate the test statistic. Okay. So the test statistic, you're going to calculate it. This is simply involves you comparing a value that can be compared. You are simply computing, you are finding a value that can be compared against the theoretical distribution to determine the likelihood of the observed data under the now hypothesis test that you made in the first statement. Okay. Then after now you've computed that value, you are going to do what? You are going to make a decision. So making a decision simply involves you comparing the test statistic to a critical value, or you're going to use a p-value to decide whether you're going to reject the null hypothesis test that you made or you are going to accept it. Okay. Now you reach a conclusion to say, is this decision making sense? Is it not making sense? Okay, so those are simply the basics on hypothesis test. Okay, so now you're going to see also the formula that you can use for the hypothesis test. What formula are you going to use? You're going to see how you can use that formula now to answer questions that you're given. Okay, so let's look at this example. So in this example, we are saying a researcher believes that the average IQ of a certain population, okay, is 100. That is what the researcher believes. So now, the researcher believes that the average IQ of a certain population is 100. Okay. So a random sample of 50 individuals from the population yields a mean IQ score of 105 with a standard deviation of 10. What is the question saying? conduct a z-test to determine if the researcher's claim was supported, or the researcher's claim is supported by a significance level of 0.01. Okay, so now we are told a researcher believes the average IQ of a certain population is 100. So now a random sample of 50 individuals from the population yields a mean IQ score of 105 with a standard deviation of 10. Then now we want to conduct a z-test to determine if the researcher's claim is supported by a significance level of 0.01. Okay, so let's see how we are going to solve this question. Okay, so the first thing that you do, obviously, you have to state the hypothesis that has been given. Okay, so that's the first thing that you're going to do. So let's say the solution for this, you are going to state, okay, you state the hypothesis. Okay, you state the hypothesis for this. Okay, so now what is the hypothesis? So for the now, so the now hypothesis, which is the first thing that we have, the now hypothesis, okay, we are going to denote it as HO. Okay, for the now hypothesis, we know here we use this symbol mu. Okay, let me just write it nicely. We use this symbol mu, which is 100. So the observation was made on a population of 100. Okay, that is a now hypothesis that we have. What is our alternative hypothesis? Okay, so for the alternative hypothesis that we are going to have, the the hy- alternative hypothesis, which we are going to write it as HA. Here mu is not equal to 100. That is an alternative. So we want to know if there is another population of that is not equal to 100, or it is equal to 100. But in this case, the alternative that we have is that uh, the average IQ of a certain population is not equal to 100. So is this claim supported, or maybe it is not equal to 100? So in this case, you're going to look at a video on how you can know if it is a two-tailed test or it's a one-tailed test. So in this case, this is a two-tailed test. So of course, maybe let me explain what a two-tailed test and a one-tailed test is all about. So if a research does not specify anything, that is a two-tailed test. If a research it specifies something, maybe they tell you the population is at least this and this is more than, so you know, of course, it specifies what you have. So that one is a one-tailed test. But in this case, it doesn't specify anything. So of course, we're simply determining to see if the IQ for the 100 population that we have. Okay, so in this case, what you have, it is a two-tailed test. Okay, so now the first thing, you state the hypothesis of which we've done. So we have a mu which is 100 there. That is the initial population we are carrying on for a 100 sample that we have for a total population of 100. Okay, then the second thing that we do now, we choose, okay, significance level. Okay, you choose the significance level, and of course we've already been given the significant level. It is 0.01. Okay, that is the significance level that we have, 0.01. That is what we've been given. Okay, so we have the significance level of 0.01. Now we have to calculate the statistic test. Okay, the test statistic, we calculate that value. We want to compute that value, and we want to find it. We want to find that value. So here you are going to calculate, you calculate the test statistic. Okay, so now let's see what are we given on the mean. So we are going to use this x, okay, x bar, okay, x bar. In that case, that simply means the sample mean that we have. What is our sample mean? We have the sample mean of 105 according to the question. Okay, that is the sample mean. What is the mean population? So the mean population, which is given as mu, the mean population we are carrying it on 100. That is the mean population that we have. So there we have got the first thing that we have, 105 represent the sample mean. Then the mu, which is 100, represent the population mean. Okay. Then we are going to look at the standard deviation that was done. The standard deviation, we are told it is 10. Okay, that is for the standard deviation. Then what is the sample size? Okay, the sample size, we are going to represent it with n. The sample size is simply equal to 50. That is what we are told. Okay, so now the sample size is equal to 50. The population mean is 105. The population mean is the population mean, I mean, is 105, 100. Then the sample mean is simply 105. The standard deviation, we are told it's 10, and the sample size, we are told it's 50. So now let's use the formula, okay, to find the significance level for that, okay, because that is what we are looking for. So now let's use the formula and see how far we can go. Okay, just a minute. Yes, use the formula and see how we are going to solve this question. Okay, so now we've stated this. We've stated this. So now let's use the formula. I just hope it will fit here. So in this side, I'm going to use this formula. Okay, so I'm going to use the formula here. So the formula, which is because you're using the z test, so z will be equal to z will be equal to the sample mean minus mu, which is 100, representing the population mean, over, then they are going to have the standard deviation. This standard deviation, you are dividing it by the root of n. Okay, you are dividing it the root of n. So in this case, what are you going to have? You have 105 minus 100. Okay, everything you are dividing by the standard deviation, which is 10. This is being divided by, okay, you are dividing by the root of 50, because that's the sample size, the root of 50. Okay, that is the root of 50. So in this case, what are you going to have? You are going to have 5. Here you have 5 over, here you have got 10. Use your calculator to find the root of 50, square root of 50, or the root of 50. You are simply going to have 7. You get 7.07. So you get 7.07 here. Okay, 7.07. So let me just erase here so that we can solve nicely. Okay, so I'll continue from this point. I'm bringing it here. So from this point, I'm taking it here. So there we are going to have, we have 5 divided by 10. This is also divided by 7.07, and this will give you 5 over 1.414, and this, it will give you 3 point, okay, 536. That is the value that you have. So that value that you have is a test statistic. Okay, so now you found that. Let's determine the critical value or the p-value. Okay, so now let me just erase here a bit. So now we've calculated, we've calculated the statistic test. Now let's look at what we can do. Okay, hope you are following closely. So now let's look at 4. For 4, we simply say you're going to determine, the critical value. Okay, you determine the critical values in that case. Okay, so you determine the critical values or the critical value. So for a two test, okay, so we have alpha, which is 0.01. That is our significant test, which is 0.01. So the critical values at this point, okay, the critical z values. So if it is for a two-tailed test, you simply multiply by 2. So these values are going to have positive or negative 2.576. Okay, this is the value that you have. So you know there's a degree of freedom that you have, so that is n minus 1. So you're going to use that sample space that you have, then you compare these. So for you to determine the critical value, so you know the significant value level that we have is 0.01. So now this is a two test. You simply multiply by 2, then that you subtract from the actual number that you are given for n, which is it 50, the value that you have, which is 1.4, then you subtract that. What are you going to get? So you're going to have 2.576. Now if this is the value that you have, okay, so now that value that you have, we are comparing those two values. So now if you check this value that you have there, which is 3.536, okay, that is the calculated z value. That's the one that we did for the statistic test. You find 3.536, and that value is greater than what? It is greater than this critical value that we determined. So this value should check 3.536. This is greater than 2.576. So now, since that value is greater, so we reject, okay? We are going to do what? We are going to reject the null hypothesis. Okay, that is our decision. We are going to reject that. Okay, so now we are going to reject the hypothesis test that we are going the null hypothesis. I mean, the null hypothesis, we're going to reject it. Then what will be our conclusion? Since we are rejecting it? Okay, so now the final stage, you said there are 5 steps that you follow. So now for the final conclusion, let me just erase this one here. So for the final conclusion, the 5th step, okay, Okay. Step number 5. The fifth step, you are going to conclude to say there is, so since now we've seen that that value is greater than what we determined, so there is a significant evidence. Okay, we are going to have significant evidence to suggest, so there is significant evidence to suggest that the average IQ of the population is different from 100. So that is our conclusion. So there is significant evidence to suggest that the average IQ of the population is different from 100. Okay. So now those are the basics on the hypothesis test, and let's look at two more examples and see if they will make sense.